Okay, Assalamualaikum. So in this video, I'm going to discuss the the exercise 6.1.2. Okay, so but here, okay, so 6.1.2. So I choose number 3. Okay, I choose number 3. You can try the number 1 and number 2. Okay. Okay, so I modified the question a little bit. I give a probability here in this question. Okay, so the probability value for the exercise 6.1.2 for the number 1, number 2 already upload in column. Okay, you can find in week 14. Okay, I put there is a probability for exercise 6.1.2. So you can find lah for the number 1 and number 2. So in this case, I just put here the probability. Okay, so no need to worry about the probability already given in your question. Okay, in final letter already given in your question if you have this kind of question lah. Okay, so random sample of the 300 consultation session reveal the following distribution of the consultation length. Okay, in hour. Okay, so the concentration length here. Okay, so at 0.01 significant level, does consultation length follow a normal distribution with mu 2.8 and sigma 0.97? So normal distribution, that's why you are given here the category here in the form of interval. Okay, so the consultation length here, we can we can say that it is a variable. Okay, the concentration length, the data that being collected here, it is about the concentration length. Okay. Okay. So random sample of the 300 consultation session. So 300 here, that's your n. Okay, so consultation length, it is your variable. Okay, variable. So does a consultation length follow a normal distribution? So you are given mu and sigma here, so means that both parameter given in this question. Okay, so we start with the step 1, H null. So it fits already. So here is a consultation length follow a normal distribution. Okay, so H1, okay, consultation length do not follow normal distribution. And claim is not very important here lah. Okay, no need to state the claim. So step 2, we need to calculate the chi-square. So you are given the probability, you have the frequency here is a OI. Okay, probability here is a PI. So I just add here the column for the E. So EI. Okay, so we know that we have 300 times with the probability here. Okay, I just put here 300 times, 300 times, 300 times, 300 times. So why I put here? Because I don't have enough space here lah. Okay, I don't have enough space, that's why I put here. But the formula here you can put here lah. Okay, so you will get 300 times 0.0298. So 8.94. Okay, remember that it must be in 4 decimal places, but here you just have 2 decimal, then just put 2 decimal lah. Okay, just write 2 decimal places. The second one, so 5.19. Okay, the third one, 113.07, and the fourth one 9309. Okay, if you find the summation of your E here, you get 22029. Okay, so the summation here, okay, what we call the probability that we get E correct, okay, will be higher if the summation here quite similar to the n, okay, because the n is a summation of O. Okay, so in this case, because of the probability, it is quite far from the n, which is 300, but still not really too far lah. Okay, so the probability that we get E correct is higher lah. Okay, if we have Poisson and binomial, then it will be much closer lah. Okay, but there is no there is no rule to say that how much different that we need. But if it is quite close, then the probability that the E here is correct higher lah. Okay, so then we check the E. So in this case, all the E greater than 5, then you can proceed with the chi-square. No need to combine any category. So chi-square test here, it is similar as a categorical data that we discussed last week. Okay, the formula. So O minus E for the first category, square divided by E, plus second category, third category, and the last one, fourth category. Okay, so the summation of this, we have 35.9182. Okay, so step 3, critical value. So it is always write the test. So chi-square, probability value 0.01, degree of freedom k minus m minus 1. So in this case, k 4, 1, 2, 3, 4. So okay, I just wrote here 4. M, the number of parameters that we calculate from the sample data, but here both parameter given for the normal. So M 0 minus 1, so we have 3. So find your statistical table, you will have 11.3449. Okay, and then step 4, decision. As I said, you can plot here where is your chi-square, so that it will be clear, okay, what is your decision. Okay, so chi-square, okay, somewhere here which is greater than critical value. If you plot, make sure to label. So chi-square in the rejection region means that it is reject hash null. So chi-square test greater than critical value, then reject hash null. So reject hash null means that, okay, reject hash null means that we say no to the null hypothesis. So we support the hash 1. So the conclusion here, step 5 conclusion, you can write the statement of hash 1. Okay, so at alpha 0.01, consultation length, do not follow normal distribution. Okay, so I think that's it for the exercise 6.1.2. Hopefully that you do understand. okay, what I'm discuss here. Okay, I tell you the secret lah. Okay, before these students are afraid, very afraid with the fitting of the distribution because of the probability. Okay, some students, they don't know how to calculate the probability, and I admit that, I agree that for the fitting of the distribution, the crucial part is a probability. But now probability is given in your question, then it should be easy lah. Okay, so if anything, you can always ask your lecturer lah. Okay, or you can ask me. Okay, for my student, you are suggested lah to ask your own lecturer, and my student should be me lah. Okay, thank you.